Hang on a second, yeah. Okay, a wedge is cut out of a right circular cylinder of radius 4 by 2 planes. So let's visualize this. Here's a right circular cylinder of radius 4, and we're going to cut a wedge out with 2 planes. One plane is perpendicular to the vertical axis of the cylinder. So here's the vertical axis of the cylinder, and one plane slices like this. The other plane intersects the first at an angle of 30 degrees along the diameter of the cylinder. So what we're getting is we're getting a slice of cheese, a wedge cut out of this, where if you can kind of visualize looking at the side of the wedge, if I look at the wedge like this, and I look at the side, this is what's happening. I'm pulling a triangular piece out, and if I look at the top of the, like on the side of the wedge, we'll kind of call this a side view, I get 30 degrees right there, and it says that I have a radius of 4, so we know that, but so let's keep going. Wedge is cut out of the right circular thing. One plane is perpendicular to the vertical axis of the cylinder, and the other intersects the first at an angle of 30 degrees along the diameter of the cylinder. Yep, that's all I need. So this wedge is cut out that way. And then height-wise, if I look down, this is going to be a top view. This is what it's looking like. So this is tricky. It's tricky visualizing this. I'm going to go down here to the very, very end because I think I had a visual of what this kind of looks like. We just need to see if the wedge is starting from the center and coming out, or if it's truly like coming like this. So let's sort of go back to this one. Is it going from the center? One plane is perpendicular. The other intersects the first at an angle of 30 degrees along a diameter of the cylinder. So it intersects the first along the diameter. That's the clue that this is actually, it's not like this, it's more like this. That's a top view. So let's come back down to this thing. Okay, now we can kind of see how this is looking. You guys see the side view and the top view a little bit? This was a cylinder. This picture can be applied to both of them. There's no real reason that it can't be. So here's the cylinder, and you had a plane come through like slice like that and slice like this, and you created a wedge. Okay, seeing this a little bit better? Just a little bit. So this wedge is being pulled out like a little block of cheese. Yum. It also says that this radius is 4, so I know that is 4. I know this is 8 right here, although I might not need all these little things. I have the radius is 4. Okay. We need to figure out what the best slices that we can take of this wedge are. I'm going to keep this image on the left here because this is very valuable. What's the best slice that I can take? Vertical slice coming down. Which shape would a vertical slice probably take? If I did a slice like this and then moved over like that and then came back down and then moved over like this. A rectangle. The slice is going to be a rectangle. As it slides left and right, it's going to increase and decrease, and its dimensions are going to change a little bit. But it's going to be a rectangle. So let's pull a slice view out, and I'm going to have a rectangle like this. Okay. Now, the rectangle, if I keep tracking it down, this is what's going to be a little bit tricky about this. We need to get the dimensions of the rectangle down. This little piece of the rectangle right there, this little piece right here, that is y. That's the height of the semicircle. And for this, y is equal to root, is it radius of 4? Yeah, root 16 minus x squared. So that is y. Now here's the fun part of this. The height of this, we'll call this h for now. Wouldn't that be coming from this right here, which is also the height of this thing? To get the height, I need to know what this equation is, y equals something times x. I need to know what the tilt of that is. And there are basically like 3 primary ways you've learned to do an angle. You've learned degrees, you've learned radians, and you've actually learned slope. Slope is a way to do the angle. What would the slope of this be here? And just to give you a little reminder, on any 30, 60, 90 triangle, you know the side lengths. 1, 2, and root 3. So the slope of this line would be what? 1 over root 3. Good. Up 1 over root 3. Change in y over change in x. Which means that I know that an equation for the line here would be y is equal to 1 over root 3 times x. That means that whatever the x position is, the y position, the height of that is 1 over root 3x. Which means that I can actually call the height here, we're going to redo this triangle, or this rectangle just a little bit here. Height is 1 over root 3x. And my base here is actually 2y. This is y and y. And 2y is 2 times root 16 minus x squared. 16 minus x squared under radical is the equation of a semicircle with radius 4. For any semicircle, y is equal to the square root of r squared minus x squared. Because if I square both sides and move the x squared over, I just have x squared plus y squared equals r squared. So this now gives me the dimensions of that rectangle entirely in terms of x. Integral, I'm sliding from the left and right, 0 to 4, of, we need to do the area of this rectangle, so 1 over root 3x times 2 root 16 minus x squared dx. So if it's all this, let's pull out our constant multipliers. 2 over root 3, and I have x root 16 minus x squared dx. What's the strategy I'm going to use to integrate this? U substitution. U is equal to 16 minus x squared. Du is negative 2x dx. dx is negative 1/2. Negative 1 over 2x, my bad. Du. It's going to cancel the x out. It's going to pull out a negative 1/2. The negative 1/2 is going to multiply by the 2 over root 3 to give me negative 1 over root 3. We, of course, are going to substitute our limits in and change our limits of integration. So plug in 0 and I get 16. Plug in 4 and I get 0. Root u du. Notice how I have 16 on the bottom and 0 on the top, but my leading coefficient is negative. We can switch those. So I get 0 to 16. I'm going to express this as u to the 1/2 now. It's kind of getting ready to integrate. Integral of u to the 1/2 is 2/3 u to the 3/2. So we're going to pull the 2/3 out, keep this as 1 over root 3. Then this is u to the 3/2 evaluated from 0 to 16. Finally, 16 to the 3/2 is the square root of 16 cubed. So that's 64. 64 times 2 is 128. I get 128 over 3 root 3, which is fine to leave it like that. And we're done. Sammy's wrong. 16 to the 3/2 is 64. Square root of 16. Okay. I'm going to stop that.